Hi, everyone, and thanks for joining today. Welcome to today's webinar, Best Practices to Measure the Color of Orange Juice and Other Liquids. Presenting today is Tim Mouw, our Applications Engineering and Technical Support Manager at X-Rite. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few quick things to go over before we get started. Due to the number of people that are attending today's webinar, we will keep everyone muted. If you have any questions, please use the questions function on the GoToWebinar panel, and we will definitely have some time at the end of this webinar to answer a few of your questions. Finally, this webinar will be recorded and you'll receive a link so that you can review the webinar at your convenience. This recording typically goes out tomorrow. So with that, I'll turn it over to Tim to get things started.
Thank you, Robert, and welcome everyone. Good morning or good afternoon or good evening, depending on where you are. As Robert said, we're here today to talk briefly. Our webinars are 10 to 15 minutes long to talk about measuring the color of orange juice, a pretty specific thing, but also about other liquids. Not some of them might be food-based as well, might be other juices, but virtually any liquid is going to be applicable to the things we talk about today. So let's dive in. So the first question is, what are you measuring? And when we ask that, it's not so much about its chemical makeup or anything at this point, but more about the opacity or transparency of the liquid that you're measuring is key, because it's going to help us determine how we measure it. So as the title of our webinar says, it could be orange juice. An orange juice that looks like that, right? And orange juice is fairly opaque. You can't see through it. Now light passes through it, right? It does illuminate from behind as well, right? But it's not translucent by any stretch of the imagination. So it's a fairly opaque thing. So maybe fruit juices are always going to be opaque. Well, not if we look at apple juice. You can buy apple juice that looks like that, and it's very, very clear or transparent. Again, it's got color to it, yes, but it's transparent. So maybe it depends what fruit. Well, that's not even true, because let's look at apple cider. Apple cider in opacity, for example, is much more like orange juice. So the transparency and the opacity of the liquid is really key, because it's going to help us determine potentially the right way to measure it, as well as things we want to determine will help determine the right way to measure it. Now, we can extend that into things like dyes, right? Here's a picture of a bunch of jars of different dye liquids. They could be different juices. They could be, I don't know, maybe it's Gatorade or Kool-Aid, or maybe it's dyes that you're going to use to color something, right? It could be chemicals that are in different colors. Again, how we want to measure those, a lot has to do with opacity and transparency. And then the last example is just one of my favorites. Lots of us love to drink beer, and just think about that. If you were needing to measure the color of that, obviously a really dark stout beer, you're probably not going to measure is not transparent. You're going to have difficulty measuring that in a transmission chamber versus a light beer that's pretty transparent and maybe could be measured that way. And believe it or not, if you don't know that, there are customers who are measuring beer and those kinds of colors. So that's where we are, looking at a variety of things we might be needing to measure. So let's move on. So the next question is, what are we going to measure it with? Well, we're typically going to be measuring with a benchtop spectrophotometer. It might be one like this. That's a CI 7520. There's also a CI 7500 that looks exactly the same. That's a reflectance only device. Might be a CI 7600. We have several other models as well. The difference you'll notice in the one on the right, the 7600, is it has a door on the top that will slide open to allow us to do transmission measurement. Now, we don't just need an instrument. We're going to measure liquid. It's not like when I have a piece of plastic or something that's physically solid that I can simply place at the front of the instrument and use that little arm to hold it in place. Liquid presents an issue. So I've got to have a way to present liquid to the device without contaminating the device. So the 7520, for example, and in fact, actually both of these instruments are approved by the USDA for measuring the color of orange juice. And you may need to use, if you're doing that, you need to use a fixture like this OJ test tube holder. You can see that's kind of a plate that fits right up on the instrument. I don't know if you can see my cursor or not, but would fit right up here where the silver 25 millimeter aperture plate is. That plate would go in its place. It's got an opening in it to be able to put a test tube in there and measure the color, the reflectance of the color of orange juice. That's the way orange juice gets measured. And that orange juice test tube holder will work on either of those instruments. Now, if I determine I need to do some transmission measurements, I'm going to need a transmission kit, and we'll see more detail about both of these in a bit, about how we would go about actually using these fixtures and these instruments to do measurements. So let's take a look at that. So reflectance measurement. If I'm going to measure orange juice or an opaque liquid, I'm going to put it into a tube like that. And you can see here the person has the juice in the tube. They're going to insert it into that holder, and then they're going to place that holder up against the device like that, and now I can measure the color of that juice. Now, there's also holders like that that will hold a cuvette. Cuvette is, if you're not familiar, is essentially a square glass container that'll allow us to measure liquid. So you could do it with a cuvette. You could do it with this orange juice holder, which happens to have a black surround. That's the way that test is defined. We also make one that's got a white surround on the inside. And of course, because those colors, they might be near opaque, but they're not completely opaque, so the color of the background will matter. But pretty obvious here, I can put the liquid, orange juice in this case, into that holder and take a measurement. Now, what if I want to measure the transmission of the light? In other words, now I'm going to measure the light passing through the sample. So here you can see a cuvette, as I described earlier, the glass rectangular piece there. It's in the transmission kit, which magnetically seals into place right there. This is the 7600 instrument with its transmission door open, so I can get inside. On the left of this picture, to the front, would be where the reflectance measurement happens. And so to the left is where the sphere and the illumination, the light is. And the light's going to pass through that. And to the right side of this is where the optics would be. So let's take a look at another picture that shows that. So here's a cuvette that's got some, I don't know, pinkish liquid in it. Don't know specifically what it is, but we're going to be able to measure now the light passing through that sample. So we've got two ways to acquire data. We can do it through transmission measurement. We can do it through reflectance measurement. And in both cases, we're going to get a percentage of light that either passed through the sample or reflected off of the sample. And with that, we get data. Okay? So then what can that data tell us? Well, it can tell us if if our color is consistent. In some cases, we're producing something, and we might be able to adjust our blend of things to make the color different. Some cases, we're measuring something like juice that's coming from an orange. If I want 100% juice, I can't artificially color that, so I'm measuring something that's naturally occurring. But either way, I can do it in several different ways. I can use standard CIE color metrics and tolerances, and in the software, I might plot something like this, where I've got a color standard measured, I'm measuring samples against it, I'm judging whether they pass or fail, whatever tolerance I set. Pretty straightforward kind of color metrics. Again, those can happen whether it's reflectance or transmission measurement. I might need to meet a specific index. For example, there is an actual color calculation called the orange juice index. It looks like that. It's just one number, the OJ number that we get when we measure orange juice using those specific instruments with that holder and so forth to measure the color of the juice. Okay, so what else does that data tell us? Well, it might help me grade my product. I mentioned sometimes we're measuring things that are naturally occurring, like juices that are coming naturally from fruit or vegetables, I guess, as well. So we want to measure the color of that and not artificially alter it. So we need to grade that color and grade the product, just like, you know, the beef you buy has a grade, and the eggs you buy have a grade, and lots of things have a grade. Color can be part of that for things like juices. And so for those kinds of products, color is part of the grade or the score. Might even be the same in petrochemical in some places, right? Where a different color gives you a different grade. And typically, you get a better grade, it's worth more money, right? So it's a significant issue. It's something significant to be testing and validating, to be able to grade it higher, grade A versus grade B versus grade whatever else. And the higher the grade, the better the grade, the higher the price, the higher the value of the product. The color data can also tell us what I need to adjust. So if it's a dye bath where I've mixed multiple things together, measuring it will let me quantify and calculate what I need to add to fix it. But it also can tell me other things, like if it's too opaque, I'm assuming here I'm doing a transmission measurement. If it's too opaque, not enough light is passing through, maybe I need to further filter it, right? Because maybe I'm getting transparency. Think of apple juice, right? When you squeeze an apple, it's really apple cider because it's got pulp and everything in it. It's filtering out the pulp that gives it that transparency. So maybe it's not transparent enough. Maybe I need to filter it further, or maybe I am diluting it and I need to do that. If it's too transparent, maybe it's because I don't have enough of what the coloring material is in there, and I need to increase the concentration of that. Those are just some of the things that the data can tell us when we're doing these kinds of measurements. And the last thing we want to go through here is talking about measurement considerations, things we have to keep in mind. Some of these apply to any kind of color measurement, but some of them are more specific to measuring liquids and juices, okay? So instrument calibration. Yes, we always need to calibrate an instrument, but when we're using a fixture, and specifically when we're doing transmission measurement, we have to calibrate for the fixture and the method in a transmission measurement, because everything you measure will be passing through that cuvette. For example, you're going to calibrate your instrument with that cuvette in place with either air or a clear liquid in the cuvette, essentially calibrating out the effect the glass has, so that when you get a measurement, you're really just getting a measurement that's part of the liquid. Okay? So we've got to have that considered. And then sample preparation and presentation. These are really critical. The fixture, again, we have to ensure that the fixture is properly in place, so it's not interfering with the light, and that the cuvette or the tube, whatever we're putting the liquid in, is clean. Not only the inside, but also that you're not grabbing it with your hand and putting fingerprints in the glass, because anything that you do there is going to have an impact and be interpreted as a color difference. So you've got to be very careful about the fixturing and the container, the glass that's holding your liquid. We might have to consider dilution. Sometimes we want to do a transmission measurement because it gives us some advantages, potential advantages in measuring transmission versus reflectance. And in order to do that, we need to dilute the solution, or dilute the liquid and make a solution, right? That lets more light pass through. So dilution may be necessary to increase light transmission. Temperature, we have to be aware of this. Like most objects, liquids can be, that big word, thermochromatic. And that simply means that an object, and this is true of a piece of ceramic tile or plastic or paint or ink on paper, and it's true of liquids and other things as well. As their temperature changes, their color literally changes, both visually and in a measured sense. So we want to make sure, if we're measuring liquid, that we're measuring it at a consistent temperature. Because if we measure the same liquid at two different temperatures, 10 degrees Fahrenheit different, for example, we could have a color difference that's being seen and measured. And so we have to be careful about that. And lastly, with liquids, this one's really key. I just call it time, and say things like particulates may settle. So think about, we'll go back with orange juice as an example, or any kind of fruit juice. If I were to pour it into a tube and then put the tube in the holder and take a measurement, I'll get a color value. If I let that tube sit there for 3 minutes and then measure it again, is there the potential that the color will be different? Sure, because maybe the fruit pulp that's in there is slowly settling. Even the fact that you've all seen there are some kinds of liquids, when you pour them into a clear glass or whatever, they look like they're moving for a while, right? We've got to wait for that to settle down so that we're not taking a measurement while there's that change going on. So it's important that we know how long we're going to let it sit before we measure it, that we aren't pouring it in and measuring immediately, because that could be a color difference being created, a false color difference in reality. And lastly, documentation. It's about documenting all of these things, defining the parameters for the entire process to ensure repeatable and reproducible results. You need SOPs, standard operating procedures, for exactly how it's going to happen so that you can be consistent in how you do your measurements. So to kind of wrap things up, number one, we need to determine the type of measurement to be used based on several things. One of the most important is the properties of the liquid or the juice that you're going to be measuring. That may drive you to choose whether you're going to do reflectance or transmission. The second point also contributes to that. And the second point is we need to identify the metrics that we're going to use for measurement analysis, because you may need to use one specific to what you measure, and your metric may drive to one thing, right? You might, as an example, if you were going to measure orange juice, you might say, I'm going to measure it, I think I'll dilute it and measure it transmission. Well, you can do that, but if you want to do this orange juice index, that's going to drive you to the fact you have to do a reflectance measurement, because that's the way that that is calculated. So both the properties of the liquid and what you need to get out of your measurements are going to drive you to how you go about measuring it. And then lastly, you want to ensure that everyone is using the same methods. Sample prep, the same way that they're measuring, reflectance or transmission, even things like there are different size cuvettes that are thicker and thinner, right? Or you're using the test tube holder to do reflectance. Are you using the black surround one or the white surround one? All those variables all need to be documented so that we can ensure everybody's using them the same, to ensure that we get data compatibility. Because ultimately, that way you'll know your results reflect the results that other people would get if they were to measure the same thing. And that's what it's about, consistency and compatibility in the data. So that brings us to our questions. I'm going to take a look at the questions panel to take a look at any questions that may have popped up. Feel free to ask those. And Robert's also going to present you with another poll while I take a look at the questions. Yeah, we've got a couple of questions, so let's go ahead and dive in. One was about the kind of instruments that that we were showing. Those benchtop instruments are spherical, is the generic way that we talk about them. Their geometry is actually D8, meaning a diffuse illumination, 8-degree sample measurement. So that's the type of instrument that they're using. Internally, those two instruments are the same. That's why we can use either of them to do the reflectance measurement and get the same results. It's just one of them is not equipped to also do the transmission measurement, but otherwise those devices are the same. So question about transmission measurements. So someone asked, if you're measuring the color of many different clear liquids that might have different viscosities, like their sugar solutions, would it be best to calibrate with the uncolored base liquid between each sample? Or should we use air in the cuvette? I would recommend it this way. So typically we say this: if the base liquid is going to be the same for all of those, and they just have different concentrations or different different viscosities, even the viscosity tends to be okay, if it's the same base liquid, you want to calibrate it with that base liquid in place, so that essentially then what you're doing is you're also calibrating out the liquid, right? And the only effect you're going to be measuring when you do your transmission measurement then is the difference that's caused by the different concentrations of whatever is in the liquid. Now, you could also, if there is a significant difference and you have multiple bases that are clear, but their viscosity or other things differ between them, I would probably start that myself by calibrating with one and measuring the others, just to see if they are contributing to it or not. And the software will allow you to have multiple calibration modes that you can name whatever you want. So you can have a calibration mode named for each of the different kinds of liquids you need to measure. But it's a good way to be able to control that. Okay. I had a question I saw about part numbers for the various accessories that we showed. I don't have those numbers at hand, but we will certainly reach out and share those. And then the last question, how important is it to use optical quality test tubes? Well, it's pretty important because we're always going to be measuring through the glass. And obviously, while you might say, yes, we're going to perfectly clean that same test tube and reuse it for forever, that's not reality, because somebody's going to drop it and it's going to break. Or you're going to be measuring so many samples that you can't possibly justify the time to clean them in between each measurement. So you're going to want to have multiple tubes that you can use. So it's pretty important that those are optically have optical quality. I like the way the question was phrased. And I even would recommend, if you're getting a batch of those, again, do a test. You can measure them with nothing in them and measure multiple of tubes, right? And compare them to one another to see if they are contributing or how much. They will be contributing some difference, because even a high quality optical glass isn't perfect. The reason, though, that you need that is because typically when you're doing that, it's glass that is very tightly controlled, specifically for its thickness as well as its content. And so that will ensure that you're not getting false measurements, right? You don't want to get a measurement that you think there's a color issue with your product when it's really just that particular tube or cuvette you're using is of a different quality, and thus it's contributing to the color, because the glass is a little thinner or a little thicker, and it's going to make the color different because the light will bend differently going through that glass. So it's pretty important to do that. Okay. All right, we have a few other questions, but we're running out. We have run out of our time slot. So if you've asked a question and we didn't get to it, we will commit that we will get back to you. We will answer your question and provide you with that information. Thank you again for your time. It was a pleasure speaking with you all today, and I wish you all a very healthy, happy, and safe day. Thank you.